Hi, A&Pers. This is Dr. Jones checking in. This is a video lecture for A&P 2, lecture test 1, video. We're on 9, and we're starting on page 21. I have had a series of tech issues, but I think we're actually recording this time, and the computer hasn't shut itself down yet. So we are good to go. Yay. All right, so I have us at the top of page 21 in the note set. So the regions of the ear, and there's our page number, page 21. And I'm pretty sure this is not the slide we needed to be on. Yeah, we started ears. Okay, so the anatomical regions of the ear, we have the external ear or outer ear. And the function is to collect and direct sound waves to the middle ear. The middle ear, did that just like flash and turn off? Great. The middle ear collects and amplifies sound waves and transmits them to the inner ear. And the inner ear or internal ear does your hearing and equilibrium. So outer ear, middle ear, and then this weird structure here is the whole inner ear. If you've watched the lab videos, you'll know we have an inner ear model. It's like this thing, but like this big. Lots of fun. Oh, structures. So the ear itself is the auricle or pinna, and the ear hole. We're not calling it the ear hole. We're calling it the external acoustic meatus, acoustic like a guitar. And it ends at this membrane, which is the tympanic membrane, eardrum. And behind it is the tympanic cavity, and that connects to, that one's not next. Do you think these are next? Okay, these three together are that one wasn't next. Okay, so this was next. This is the round window. This is how the sound wave get out of the inner ear. And this part here is the vestibule. And then this tube that connects the tympanic cavity to the back of the throat is the auditory tube. When I was a kid, it was the eustachian tube, so same thing. And then this spiral ciminal bit is the cochlea. Cochlea is for hearing. And the bony labyrinth is the outer bony layer of the whole inner ear. And then we have this nerve, vestibulocochlear nerve. This includes part from the vestibule and the cochlea. I don't think we usually oh, hello? Is that from the last time yeah, all right. Okay. There you go. Report from the last tech issue, apparently. So the vestibulocochlear nerve, also known as the auditory nerve, comes from both the vestibule, which the vestibular complex will include the semicircular canals and the vestibule itself, and then the cochlea. Sorry, my dog's going crazy because there's somebody on my front porch, but the fan can get it. So the vestibular cochlear nerve does hearing, which is from the cochlea, and balance, which is from the vestibular complex. The vestibular complex includes the vestibule and the three semicircular canals. We'll talk about that today. And that behind my picture says semicircular canals. And then under this base of the stapes is the oval window. And then these three bones together as a group are the auditory ossicles. Excellent. In order, they are the malleus, the incus, and the stapes. So that starts with M-I-S, so don't miss them. Malleus, incus, stapes, M-I-S, don't miss that. So bottom line, how this works, and I'll give you just the basic concepts as much as I can without the terms that we haven't covered yet. The sound waves, and I'll talk here in a second about what sound waves are. No, I'll talk right now about what sound waves are. Okay, so wait, what's the next picture? Yeah, okay. So the sound waves are compressions of air molecules that are closer together or further apart. In the external ear, we find, I think you all can see the arrow, but let's do a laser pointer. The ceruminous glands, they make cerumen, which is earwax. So they're in the external acoustic meatus. Okay, let's go back and talk about sound waves then. So sound waves are compressions of air molecules. I really thought I had a picture of sound waves here for you. And that's a no. Okay, going back. Oh, poop. Wait, no. There we go. Pen. And I don't know what color we are. Okay, so a sound wave like me talking or the dog barking or a knock on the door are all compressions of air molecules, and they move out from their source in waves. Just like if you throw a pebble in a pond and then that energy disperses in a wave, it's the same thing, except instead of a raise of the water to disperse energy, to move the energy, it's compressions of sound waves. So there'll be like an area where the sound waves are compressed and those move out. And then there'll be an area behind it where there are fewer air molecules, and then another area where there are more air molecules. So if this is our source of the sound, then it's compressions of air molecules moving out from the source with areas with fewer air molecules in between. Sorry, I'm terrible at dot painting. Those were dots. I swear those were supposed to be dots. And so this compression of air molecules, this area with more air molecules together, is the difference between all the sounds you'll ever hear. It's a pattern of the compression of air molecules moving in waves, which is the trippiest thing ever. Like the science of sound is so weird. So weird. So your auricle, the pinna here, is a giant funnel. Your ear is just a funnel. And it funnels these sound waves into your external acoustic meatus. And then that causes vibrations of the tympanic membrane. So the tympanic membrane, the eardrum, takes the compressions of sound waves, which again, weird, so weird. It's the way it is, but it's still weird. Takes the compressions of sound waves and turns that sound energy into mechanical energy by vibrating. Just like when you're at a concert and you're too close to the speakers and like your whole chest is like vibrating and you can feel the music. Yeah, like that. Except this is your eardrum vibrating. And because you're going back a picture, not going back a picture, there we go. Because your eardrum is attached to the three auditory ossicles, as sound waves get turned into mechanical movement, mechanical vibration of the tympanic membrane. And attached to the tympanic membrane here and here is the malleus, which is attached to the incus, which is attached to the stapes. And so the malleus, incus, and stapes, and these bones are about the size of a grain of rice, like short grain rice, like little rice, not the big rice. These tiny bones inside your ear, the auditory ossicles, amplify those sound waves and then transmit them to the cochlea, to the inner ear. And so the base of the stapes sits on the oval window. The base of the stapes is an oval and it sits on the oval window. They're the same size. So you can't see the oval window when the stapes is in place. Can you not make noise? That would be great. Thanks. There's rustling in the background. I'm distracted easily. But I have coffee and we're actually recording this time. So we are all good. So the base of the stapes rocks on the oval window. and there's fluid on the other side of the oval window in the internal ear or inner ear. I forget which one's the new term. The same difference. My new note set says internal ear. What's the old note set say? Internal ear. Okay. It may have been inner ear when I was in school. Things change. Okay, so that causes waves of the fluid in the internal ear, the inner ear. Okay, and then we'll talk more once you know some terms and more of the anatomy. We'll talk about how you sense those movements in the fluid in the inner ear. Okay, so let's describe the components of the external ear. We have the auricle, the external acoustic meatus, and the tympanic membrane, and of course ceruminous glands, all of which we have discussed. The functions of the ceruminous glands at cerumen, they make earwax. The earwax helps protect your ear. It makes a waxy coating over that skin and protects it. If, say, like a bug gets in there, then it wraps that irritant up in earwax so that it does not scratch your delicate skin. So that's why. The auditory tube, again, it's what we learned as the eustachian tube, which is capital EU because capital E because it was the guy's name. So names are proper nouns and we capitalize proper nouns. So the auditory tube leads to the nasopharynx. The nasopharynx is the back of the throat behind the two nasal cavities. And it equalizes pressure on the two sides of the eardrum. So that's why when you're going up in an airplane, you have to pop your nose, hold your nostrils and blow, or chew gum, or eat something, drink something, swallow your soda or what have you. I don't drink on an airplane because, ew. I don't drink alcohol on an airplane because right now there's not a lot of people riding on airplanes anyway, though. So I'm recording this during the COVID time, so things are different now. Hopefully they'll go back. Maybe go back to something better. That would be nice. Regardless, that's why you chew gum, yawn, take a drink of something to pop your eardrums when you're going up in the airplane or you're going down in the airplane, ascending or descending. Now, if you have kids with you, it's important to have them pop their eardrums as well to help equalize the pressure, again, on the ascent and descent. Now, infants are a little harder, but sometimes a little bit easier too. For infants on the airplane, because if you don't pop those eardrums, they're going to have stretching and bulging of the eardrum like the whole trip, and they're going to be screaming the whole time, which is painful and not fair to them and not fair to you and not fair to the people around you. So for breastfeeding infants, the best thing you can do is latch them on and feed them. And for bottle-fed infants, the best thing you can do is feed them so that they're drinking, and that will help to pop those eardrums to equalize the pressure. When I say pop their eardrums, the eardrums don't pop. It's that the eustachian tube, which goes to the back of the throat, going back another here, the auditory tube is normally closed. And so when you swallow or chew gum or something like that, it pops it open briefly, just long enough to equalize the pressure on, I'm pointing, it doesn't help, on the two sides of the tympanic membrane, the eardrum. Okay. So that's why. And the functions of the, okay, auditory tube. Otitis media is a middle ear infection. So that will be an infection in this cavity here, the tympanic cavity. And it will often show as an air-water level on the eardrum so that you can see it from the external ear with one of those light things. Okay, ear scoops. Now, just because there's a fluid level on the tympanic membrane does not necessarily mean that it's an infection and not just an inflammation. However, since a buildup of fluid with nowhere to go is the perfect medium for bacterial growth. These have to be watched very carefully. What I did when my kids were little, because antibiotics for ear infections actually increases the incidence of ear infections in that kid. It makes them more likely to have recurrent ear infections, and ear infections suck. So what I did with my kids was I would take them to the doctor and he would look at it and in their ear. And if he could say, yes, this looks like an infection, we need the antibiotics, then we would go on the antibiotics. But if he said, well, it's definitely inflamed, but it doesn't, I can't tell yet if it's infected, then we would go back the next day, and in between patients, he would just look in their ears real quick and say, it looks about the same, come back tomorrow. And we would go back the next day, and in between patients, he would look in their ear real quick and he would say, it looks better, go away. I don't want to see you again. They're sick again. If you have a good doctor, they will do that type of thing. Some doctors will give you a prescription for the antibiotic, but like dated 2 days later, where if they're worse 2 days later, then we can assume that it has turned into a bacterial infection and start the antibiotics. So that's also an option. And if it doesn't get worse 2 days later, if it goes away on its own, then you don't need the antibiotics and you shred the prescription. Okay. So you have options. Uh, take the antibiotics if it's a bacterial infection. If it's not a bacterial infection, keep an eye on it and make sure it doesn't turn into a bacterial infection. All right, the auditory ossicle, malleus, means hammer, like a gold is malleable because you can hammer it. Incus means anvil, and stapes means stirrup, and it like literally looks like a stirrup. So there's that. Auditory ossicles, their collective function is to amplify the mechanical waves and transmit them to the internal ear. I'm trying to remember to not say inner ear, it's kind of painful. The internal ear houses receptors for hearing and dynamic and static equilibrium. Equilibrium is balance. And there's a picture here. This, I wonder if I can move that. I don't know if I can. This outer layer, the bone-colored shell, is the bony labyrinth. And this fluid inside the bony labyrinth is perilymph. Peri means around. And then this inner membranous, because it is a membrane, is called the membranous labyrinth. And the fluid inside the membranous labyrinth is endolymph. Endo means within. So peri means around. It's around the membranous labyrinth. Endo means within. It is within the membranous labyrinth. Okay, so I like to think of this as just exactly like a glow stick, except the complete opposite. Yes, that was meant as a joke. So a glow stick is a plastic tube on the outside with a fluid in it. Inside that is a glass tube with a second different fluid inside it. And as long as you keep the glass intact and the fluids separate, they don't interact and they don't glow. And then when you're ready for the glow stick to glow, you bend it to break the glass tube, and you can hear the little glass tube breaking and kind of feel it. And then you shake it up to mix those two fluids, and then the chemical reaction causes a glow for a far too short period of time. You wake up the next morning, they're gone. It's so sad. I wish glow sticks lasted longer. It'd be much more fun. So the internal ear is just exactly like that, except the complete opposite, because the hard shell is on the outside, the bony labyrinth, and your goal is to not break it. And the bony labyrinth contains one fluid called perilymph. And the inner tube is the membranous connective tissue tube. and inside it is a second fluid called endolymph. Okay. Label the picture describing the terms. Okay. And then we have a chart, which when I click should probably come up. There we go. Pause and write this down. I'm going to keep talking, assuming that you just wrote all of this down. Okay. So there are different parts and they have different terms and different receptors and for different senses. So the bony labyrinth is the vestibule, and it contains two membranous labyrinth structures called the utricle and the saccule. The utricle is the superior one and saccule is inferior. So if you're going kind of top to bottom, it says US, us, the US and us. And the receptors, in one in the utricle and one in the saccule, are the maculae, and they monitor your static equilibrium, and we'll talk about that. The semicircular canals are also part of the vestibular complex. Vestibule and the semicircular canals are the VC, vestibular complex. And the membranous labyrinth inside the semicircular canals are the semicircular ducts. I just want to be clear here that semicircular duct is a lecture term and it is not on your lab list. As such, semicircular duct is a wrong answer on the lab test. Okay. And each of the three semicircular canals has a crista, and that is located in the ampullaric crest. Ampullaric crest. They changed it. It used to be the ampulla. Now it's got crest on it somehow. And that does your dynamic equilibrium, which we will talk about. The bony labyrinth is the cochlea, and it's the cinnamon roll, spiral, swirly bit. And the membranous labyrinth part there is the cochlear duct, which is a lab term, which is separate from the cochlea. So also the saccule and utricle are lab terms, and you'll need to know that separate from the term vestibule. And you need to know which one's the utricle and which one's the saccule. So all that. And also a lab term is spiral organ, because we have that on the model. And the sense here is hearing. You know, anyone who's had a cochlear implant, they get that so that they can hear. The round window. Do I have a picture? No. No, no picture. What about the next picture? No, next chart. Okay, so the round window, let me different my page. You don't, but I do. The round window is the thin membranous partition that separates the perilymph of the cochlea with the air-filled middle ear. It shows up very clearly on one of the models as a round window. And what happens is at the oval window, the sound waves are transmitted into the fluid of the cochlea, and the round window is where those waves of pressure are released into the air of the tympanic cavity. If you, as you age, the round window can kind of ossify over, can kind of grow bone on the edges and not be as springy as it used to be, and then you start to get kind of sound echoes as the fluid waves, the pressure waves in the cochlea aren't able to be released. So it makes it hard to hear. Okay. And the oval window is at the base of the stapes, again, that transmit the mechanical movement of the auditory ossicles into pressure waves in the fluid of the perilymph of the cochlea. So that was page 21. Let's do page 22. Let me check my timer. It says stop. What does that mean? Did it go off and I had the sound off and I didn't see it? Are we past our 30 minutes? I think we might be past our 30 minutes. Okay, so page 21 and the beginning, concepts of hearing. So this has been a video lecture for ANP2 lecture test 1, video number, this one was 9, wasn't it? Yep, 9. All right. So thank you as always for tuning in. The education must go on. Dr. J out. Control, Command, Escape. Have a good one.